Hornets, and thank you for joining me today. Today we're going to be taking a look at 4 related rates problems in preparation for your Quizzo on Friday. Now, the whole idea here is just to give us more practice working with related rates. And I've got 4 related rates problems that I have you working on today. So we're looking at water leaking onto a floor, forming a circular pool. A spherical balloon is inflated so that its radius is increasing. A conical paper cup is 10 centimeters tall with a radius of 20 centimeters. And then we have a hypothetical cube that is growing so that its length of its sides are increasing at a given rate. So if you have not yet taken a screenshot, I recommend that you do so that I may take the piece of paper away and then I can work with you on this. Alrighty, let's go ahead and take a look at the first one. Water leaking onto the floor forms a circular pool. So the whole idea here is we're going to want to start by figuring out a circular pool. So this was number 5, and if I have a circular pool, I'm just going to draw a circle. And the radius is increasing at a rate. Here's my R and R prime. R prime is increasing at a rate of 6 centimeters per minute. And we are told that our radius is 9 centimeters. Our goal is to find out how fast the area equaling pi r squared, will change. So A prime, that's dA dt, is equal to 2 pi r prime. We're now going to take our information and we're going to plug it in. So we have our 2 times pi times 9 and times 6. And we're now going to just multiply that together in order to figure out what our answer is. So you'll notice we get 54, and we should have 108 pi, and this would then be centimeters squared per minute. And there is number 5. Number 6 is working with a spherical balloon. So the formula that we want to work with in this, since we're trying to find how fast the volume of the balloon is changing, we're going to work with volume equals 4/3 pi r cubed. Once again, it's a spherical balloon. I'm going to draw myself a sphere. That radius has to change. And they tell me that the radius is increasing, so r prime is increasing at 4 centimeters per second. Our radius is 4 centimeters. Putting this into our formula to find out the rate of change in the volume gives me V prime equals 4 pi r squared r prime. I'm now going to plug in my information, 4 pi times 4 squared times 4. And then I end up with V prime equaling 16 squared pi. Let's just take a moment and find out what 16 squared is. 6, 3, 9, 6, 1, 6. And we have, 5, 256. So V prime is 256 pi. And let's just include our units, and this would be centimeters cubed, and it is per second. And that's number 6. This brings me to number 7, a conical paper cup. So I'm going to go ahead and I'm going to draw a paper cup. That's a cone. Putting in my information will give me a proportion. Remember, cones require a proportion for us to work with between our height and our radius. They tell us that the radius is 20 and the height is 10. So I'm going to go r is to h as 20 is to 10, and therefore I have r equaling 2h. Knowing that r equaling 2h, I can now substitute in the problem with the given formula. Volume equals 4/3. Let's see, that should be 1/3 Now keep in mind all these formulas are given to you. R squared h, and now I can substitute my r, 1/3 pi, and this is going to give me 2h squared h. So volume is equal to, make sure you can see that, 4/3 pi, and I now have h cubed. So I can now find volume prime is equal to 4 pi h squared h prime. They tell me that the cup is being filled at a rate so that the water is rising at a level. So that's my h prime. That's 2 centimeters per second. And my height here is a level of 2 centimeters. So putting in this information into the formula, v prime has to equal 4 pi times 2 squared times 2, and that's giving me, 4 times 4 is 16 times 2 is 32 pi, and we're going to include our units. That's centimeters cubed per second. That leaves only number 8. Number 8 was talking about a hypothetical cube. So we're going to start by drawing a cube. And each of the sides of the cube is increasing at a constant rate. That means going down, out, and across. So let's just put it right here. So all of our sides are increasing at a constant rate of, 3 over s. Okay. So let's just see, we have volume is going to be s cubed. So v prime would be 3s squared s prime. And the sides are increasing at a given rate, so v prime equals 3s squared times 3 over s. And one of my s's is going to now get canceled. So now I have 3s times 3. And we're talking about s being 8 meters. So our v prime is going to have to be 9 times 8 times 9 times 8. And that should give me, 72. And this would be meters squared. Let's just make sure, meters cubed. And it is, do they tell me how fast? Per minute. Per minute. And that gives me number 8. So once again, my goal was just to go through and show you the process for using related rates in hopes that this helps you with this coming week's quizzle. Thank you very much, Hornets. I hope this has helped you. If you like this, please remember to click like. And if you have constructive criticism, please let me know and I'll do my best to improve. Thank you very much. Please remember, it's easy to be mean, so be nice to each other, be kind, and remember, change starts from within. Cheers. Bye-bye now.